Hi, hello, welcome to Class 8 Mathematics. This is yours Kona Kiran Reddy. My sincere thanks to all of you for watching my videos, and my sincere thanks for your great response to my videos from last few days. If you like my videos, please subscribe my channel and press like button. Write comments in comment section and share my videos on your WhatsApp groups and on social media also. Thank you once again. In today's video, I am going to solve classroom based assessment 1 question paper which was conducted by Government of AP on 2nd November 2022. Here is the question paper. So you can see that classroom based assessment 1 2022-23. This is of class 8. See section A. Here in section A, multiple choice questions we have. Each question has 4 options, out of which only one option is correct. We need to choose that correct option, right? Let us see the first problem. Which of these are rational numbers? Here we are given 37, 36.29 by 2, 25.49 and negative 37 by 69. First of all, what are rational numbers? Any number which can be written in P by Q form where P and Q are integers and Q is not equal to 0. That number is said to be rational number. Here in the given numbers we have first 37. 37 can be written as 37 by 1. So it is a rational number. Then 36.29 divided by 2. So 36.29 divided by 2. This can be written as 3629 divided by 200. Why we included these two zeros? Why? Because after the decimal point we have 1, 2. 2 digits we have. So I put 2 zeros here. So clearly this is in the form of P by Q. So this is also a rational number. So first two are rational numbers. Next we have 25.49. So 25.49. This can be written as 2549 divided by 1. Then after the decimal point we have 2 digits. So let us write 2 zeros here. So clearly this is also in P by Q form. So this is also a rational number. Now the last number is negative 37 by 69. This is already in P by Q form. So this is also a rational number. So all the given numbers are rational numbers. So in this case, all of this is the correct option. Second problem. P and Q are any two rational numbers and at the rate of is an operation such that P at the rate of Q is not equal to Q at the rate of P. So here P at the rate of Q is not equal to Q at the rate of P. You don't confuse about this at the rate. This at the rate of is nothing but an operation. That's it. Operation means you can take addition, you can take subtraction, you can take multiplication, you can take division or any other operation also. Okay, next the question is, which of these could be the operation addition? A, either addition or multiplication. B, either multiplication or division. C, either subtraction or division. D, at the rate cannot be addition, subtraction, multiplication or division, as P at the rate of Q is always equal to Q at the rate of P. So these are the options we have. Here addition, subtraction, multiplication, division. These are the operations we have. Let us check. First, if we take addition, P plus Q is not equal to Q plus P. Is it correct or not? Let us check. What are P and Q? P and Q are two rational numbers. Let us take any two rational numbers simply. Let us take P as 2 and Q as 3. So then 2 plus 3. Here Q is 3, P is 2. So 3 plus 2. Now these two are equal or not? Let us check. 2 plus 3 is 5. 3 plus 2 is also 5. These two are equal actually. But given that these two are not equal. So in the case of addition, it is not correct. Now let us take multiplication. So let us take same numbers. 2 times 3 and 3 times 2. These two are equal or not? 2 times 3 is 6. 3 times 2 is also 6. These two are equal. So in the case of multiplication also, this is not correct. So here in option A, either addition or multiplication we have. So A is not correct. Now let us check option B. either multiplication. We already verified in the case of multiplication it is not correct. Now let us check division. Let us take same numbers 2 and 3. So 2 divided by 3 is not equal to 3 divided by 2. Is it correct or not? 2 divided by 3 means this is less than 1. 3 divided by 2 means it is greater than 1. So 2 by 3 is not equal to 3 by 2. This is correct. So in the case of division, this is correct. Now here, given that either multiplication or division. So here it holds for division. That means P at the rate of Q is not equal to Q at the rate of P is correct in the case of division. Given that either multiplication or division, that means one option is correct. So we can take B as the correct answer. But let us go to C. Either subtraction or division. Here division, okay, division is correct. We already have seen that. Now subtraction, let us check. Let us take same numbers. 2 minus 3 is not equal to 3 minus 2. Is it correct or not? Let us check. 2 minus 3 is -1 and 3 minus 2 is 1. These two are not equal. So this is correct. So here in the case of C, subtraction as well as division, in both the cases P at the rate of Q is not equal to Q at the rate of P. So C is the correct option. So actually here you see in option B, either multiplication or division we are given. In the case of multiplication it is not correct, but in the case of division it is correct, right? So we can take B as the correct option, be sure. But in the case of C, here in this one, in both the cases P at the rate of Q is not equal to Q at the rate of P. In my view, B and C both are correct. And you see in case of D, cannot be addition, subtraction, multiplication or division, as P at the rate of Q is always equal to Q at the rate of P. So this is not correct actually. Why? Because P at the rate of Q is not always equal to Q at the rate of P. So that means the meaning of this one is, in the case of addition, in the case of subtraction, in the case of multiplication, in the case of division, in all the cases P at the rate of Q is equal to Q at the rate of P. That is the meaning of option D. So this is not our option. So in my view, B and C both are correct. Right, let us go to next problem. Third problem. Which of the following numbers lie between the two numbers marked on the number line below? Here we are given -8 and -7. So here if you observe the options, A, -8 by 7. This is approximately equal to -1 point something. So this is not in between -8 and -7. Now if you observe B, -7 by 8. If you take 7 by 8, this is less than 1. If you take -7 by 8, surely that is not in between -8 and -7. Now you see option C. This is -7.8. That means -7.8 means somewhere here. Right? Somewhere here, -7.8. So option C is correct. Problem 4. Which number when multiplied with 2 1/5 will result in 1? Here we are given the number 2 1 by 5. First let us write this as improper fraction. This is mixed fraction. Let us write this one as improper fraction. 5 times 2 is 10 plus 1 11. So 11 by 5. Now which number when multiplied with this one? So suppose let the number is x. X multiplied with 11 by 5 is result in 1. So that is equal to 1. Here we have 1. 1 is the multiplicative identity we know. So x is the multiplicative inverse or reciprocal of 11 by 5. So we can say x equal to how much? 5 by 11. So 5 by 11. C is the correct option. Or from this one, x times 11 by 5 equal to 1. To get the value of x, multiply both sides with 5 by 11. That is the reciprocal of 11 by 5. So x times 11 by 5 times 5 by 11 equal to 1 times 5 by 11. So 11 gets cancelled, 5 gets cancelled. So x equal to 1 times 5 by 11. So 5 by 11. So 5 by 11 is the correct option. Let us go to fifth problem. Which of the following statements is true? So out of these four, one is true. So we need to find out that. Let us see the options. A. 3 by 1 by 3, 3 divided by 1 by 3 equal to 1 by 3 divided by 3. Now 3 in the place of divided by, if you write times, then we need to take the reciprocal of 1 by 3. Reciprocal of this 1 by 3. So what is the reciprocal of 1 by 3? That is 3. Now is this equal to the right hand side value? Let us check. 1 by 3 instead of divided by, if you write times into, then we need to take the reciprocal of 3. Second one 3, we need to take the reciprocal of that one. Reciprocal of 3 is 1 by 3. Now let us check these two are equal or not. 3 times 3 is 9. Whether this is equal to 1 into 1 1 divided by 3 into 3 9. 9 equal to 1 by 9. Is it correct? No, this is not true. So option A is not correct. Let us see option B. So 3 divided by 1 by 3 divided by 3 equal to 3 divided by 1 by 3 divided by 3. Here we have some brackets actually. So first we need to simplify the values which are within the brackets. So here 3 by 1 by 3. We can write that one as 3 times reciprocal of 1 by 3 is 3. So 3. Now divided by 3. This is left side value. Right side value is 3 divided by, within the brackets, 1 by 3 divided by 3 we have. Let us write this one as times reciprocal of 3, that is 1 by 3. Now let us check whether these two are equal or not. 3 into 3 is 9, so 9 by 3 this one, which is equal to 3. Now is this equal to right side value? Let us check. 3 divided by 1 by 3 times 1 by 3 means 1 by 9. Now let us check, this is equal to 3 divided by, we can write this one as a times the reciprocal of 1 by 9 is 9. So this is equal to 27. So 3 equal to 27. Is it correct? No. So option B is also not correct. Now let us see option C. 3 divided by, within the brackets we have 3 plus 3. 3 plus 3 means 6. Okay, this is equal to, right side we have two brackets actually. 3 divided by 3. We know that 3 divided by 3 is 1. So 1 plus 3 divided by 3 again. So 1 plus 1. So here 3 divided by 6 means that is 1 by 2, which is equal to 1 plus 1 means 2. So is this correct? No, this is not correct. So option C is also not correct. So the correct answer is option D. Now let us check whether option D is also correct or not. Yeah, we know that option D is correct. Why? Because A, B, C, all these three are not correct. So option D is, it's obvious that option D is correct, but let us check. Okay. So left side value is 3 minus 1 by 3 divided by 3. So 3 minus 1 by 3. So this is equal to, we can do this as a as like mixed fraction. 3 times 3 is 9. 9 minus 1, 8. So 8 by 3. Now 8 by 3 divided by 3. This is left side. This is LH as you see. This is equal to 8 by 3. Instead of divided by, if you write times, then take the reciprocal of 3. That is 1 by 3. So this is equal to 8 times 1 is 8 divided by 3 times 3 is 9. Now let us write RHS value. This is equal to 3 divided by 3 we have. So 1 minus 1 by 3 divided by 3 we have. So we can write that one as times 1 by 3. This is equal to 1 minus 1 times 1 is 1 divided by 3 times 3 is 9. So this is equal to, as we did in previous case, we can do this just like a mixed fraction. 9 times 1 is 9 minus 1. 9 minus 1 means 8. So 8 by 9. So these two are equal. So option D is correct. Okay. Alright, let's go to next problem. Sixth problem. A rational number is one which can be written in the form of x by y, where x and y are integers and y is not 0. Y means y is in the denominator. So denominator can't be equal to 0. For example, negative 2.5 is a rational number as it can be written as negative 5 by 2. Now the question is, which of these is not a rational number? Let us see the options here. A 2.353535, B negative 1 by 4, C 3 by 0, D is 0. Here in option C, you see 3 by 0 we have. In the denominator, we have 0. So clearly, given that y is not 0, y means that is in the denominator. So denominator can't be equal to 0. Here in option C, we are given denominator equal to 0. So the number in option C, that is 3 by 0, is not a rational number. So the correct answer is C. Now let's go to next problem. Seventh problem. Which of the following rational numbers has a recurring decimal expansion? When can we say a fraction has recurring decimal expansion? We can divide, but without dividing also we can say. Whenever you have a fraction, in that fraction, in the denominator, suppose the fraction is in the simplified form. That means in the simplified form of a fraction, in the denominator, if the prime factors of the denominator are 2 or 5 or both, then it is a terminating decimal number. That means it has no recurring decimal expansion. If you have any prime factor other than 2 and 5 for the denominator, then it is a recurring decimal expansion. So now let us see option A. In option A, we have 6 by 15. Here we can cross out with 3. So 3 times 2 and 3 times 5. This is equal to 2 by 5. As I said earlier, in the denominator, the prime factorization must be 2 or 5 or both to get a terminating decimal. If you have any number other than this 2 and 5, but surely not 1, okay, then it is a recurring decimal expansion. So this is 2 by 5 is a terminating decimal as 5 is in the denominator. So A is not correct option. Now let us go to B. So 12 by 18. We can cross out these 2 by 6. 6 times 2 and this is 6 times 3. So 2 by 3. Here in the denominator we have 3. So if we have 2 or 5 in the denominator, then it is a terminating decimal number. If any number is there other than this 2 and 5, then it is a recurring decimal expansion. So here clearly we have 3. So that means there is no 2, there is no 5. So other than 2 and 5, we have 3 here. So clearly, 12 by 18 has recurring decimal expansion. So option B is correct. Okay, let's go to next problem. That is 8th problem. Which of the following points represents negative 1 2/3 on a number line? So here let us first take this one. Negative 1 2/3 we have. This can be written as negative 1 point. If you divide 2 by 3, you will get 0.6666 and so on like this. So negative 1.6666 so on like that. So that is approximately negative 1.7. Now let us check which point represent this one on this number line. Suppose if you take n, this is a positive number, so this is not correct. M, that is closer to 0, so this is not correct. And L, this is closer to negative 1, so this is not correct. Here K is closer to negative 2, so this is approximately negative 1.7. So K equal to negative 1.6666 like that. So option A is correct. Now let us go to 9th problem. In which of the following cases will the sum of P and Q be greater than the product of P and Q? So here sum of P and Q, so that means P plus Q. Then product of P and Q, so that means P into Q. Here sum of P and Q be greater than, so that means P plus Q is greater than the product of P and Q, so that means P into Q, right? So P plus Q is greater than P into Q. So in which of the following cases this is correct? That is what we need to check. So first A, when P and Q are both negative numbers, you can take some examples. Suppose P, if you take P negative 2, Q is negative 3. So minus 2 plus of minus 3 is nothing but negative 5. Now whether it is greater than P into Q, let us check. P into Q means negative 2 into negative 3. Negative 2 into negative 3 means that is positive 6. So negative 5 is greater than positive 6. Is it correct? No, this is not correct. So option A is not correct. Now let us take option B. When P and Q both lie between 0 and 1, Between 0 and 1 means you can take P equal to 0.1 and Q equal to, let us take 0.2. Now let us check in this case whether this inequality is correct or not. P, let us take 0.1 plus Q is 0.2. So is it greater than P times Q? So that means 0.1 times 0.2. 0.1 plus 0.2 is nothing but 0.3. So this is greater than 0.1 times 0.2. Whenever you are multiplying decimal numbers, first you ignore the decimal point and take the number as it is and then multiply. So here 0.1, ignore the decimal point. So it will be 1. So 1 times, here also ignore the decimal point. So 1 times 2 is 2. Now after the decimal point, how many digits we have? Let us count. Here in this case we have 1. Here in this case we have 1. So in total we have here 1, here 1. So total 2. So we need to get in the result also, we need to get after the decimal point, we need to get 2 digits. So we need to write like this, 0 like this, 0.02. If you write like this, after the decimal point we have 2 digits. 0.3 is greater than 0.02. This is correct actually. So option B is correct. Right. Now let us go to 10th problem. A rational number r is marked on the number line shown below. Which of the following number line shows the approximate location of negative 1 by r? So approximately where will be negative 1 by r? That is what we need to find out. Now observe where is r here. That is approximately at the middle of those two, right? Approximately, but not exactly. So we can take this one as nearly negative 1 by 2, right? So you see, not exactly actually, that is not exactly at the middle. But for simple calculation, I am taking as negative 1 by 2. That is r. Now what will be negative 1 by r? Negative 1 by r is nothing but negative 1 by 2. So this is equal to negative 1. Negative 1 by 2, this is in the denominator. If we bring that to numerator, that will be times 2 by negative 1. So negative 1 gets cancelled. This is equal to 2. Be sure this is the approximated value. That's it. Now you see in the options, where is this approximated value of 2? So if we take A, that is in between 0 and negative 1, this is negative value. So this is not correct. In the case of B, it is in between 0 and 1. And this is closer to 0. So this is not correct one. C, that is also in between 0 and 1. So this is also not correct. In option D, you see this is approximately equal to 2. So option D is correct. Right. Now let's go to next problem. Now let us see 11th problem. Ritu, Tarun and Imran did the following operations on negative 12 by 55 and 15 by 31. Ritu, so here Ritu added, Tarun multiplied, Imran divided. Okay, right. Let's see what is the question. Who will get a rational number? Now here you observe negative 12 by 55, this is a rational number, and 15 by 31 is also a rational number. So here we have two rational numbers. Ritu added two rational numbers. Tarun multiplied. So multiplied, and Imran divided. In the case of rational numbers, that means rational numbers are closed under the operation addition, multiplication and division. That means if you add two rational numbers, you will get again rational number. So Ritu will get rational number. Now Tarun multiplied. So if you take two rational numbers and if you multiply two rational numbers, you will again get a rational number. So Tarun will also get a rational number. Now Imran divided. So except 0, if you divide a rational number by another rational number, surely you will get another rational number. So Imran will also get a rational number. So here in the options C, you see all Ritu, Tarun and Imran all will get a rational number as the answer. So C is correct in this case. 12th problem. How many rational numbers are there between 62 by 79 and 64 by 79? If you take any two rational numbers, in between those two rational numbers, we have infinitely many rational numbers. So option D is correct in this case. Okay, now let's go to 13th problem. P and Q are two rational numbers such that their product is negative 2. So that means if you take P and Q are two rational numbers, then their product, that means P into Q, is equal to how much? Negative 2. Now, if P is negative 4 by 7, what is P by Q? So, given that P is negative 4 by 7, so in the place of P, if you write negative 4 by 7, then times Q equal to how much? Negative 2. Now, first let us find out the value of Q from this one. To get the value of Q, here we have negative 4 by 7. You can send this negative 4 by 7 to right side. So, Q will be equal to, if you send this negative 4 by 7 to right side, it will be 7 by negative 4. That means we need to take the reciprocal if you transform from left side to right side. After that we have times negative 2. Now this is minus minus gets cancelled. This is 2 times 1 and 2 times 2. So this is equal to 7 by 2. Q value is 7 by 2. Now what is that we need to find out? P by Q. Let us find out here. P by Q equal to, P is how much? P is negative 4 by 7 by, so instead of by I am writing like divided by symbol. Q is how much? 7 by 2. So this is equal to negative 4 by 7. Instead of divided by, if you write times, we need to take the reciprocal of 7 by 2. So that will be 2 by 7. So this is equal to negative 4 times 2 is negative 8. So divided by 7 times 7 is 49. So negative 8 by 49. Option D is correct. Then 14th problem. How many pieces of rope, each measuring 3/4 meters, can be cut from a 30-meter long rope? So here we have a rope of 30 meters of length. We need to cut that rope into some pieces, each measuring how much? 3 by 4 meters. So first let us take 3 by 4 equal to, let us convert this into improper fraction. 4 times 3 is 12. 12 plus 3 is 15. So 15 by 4. So length of each small piece is 15 by 4. Like that we need to cut that 30 meters long rope. So how many pieces we will get? Simply you divide. So 30 divided by 15 by 4. So this is equal to, we can write this one as 30 times. In the place of divided by, if you write times, we need to take the reciprocal of 15 by 4. Reciprocal of 15 by 4 is how much? 4 by 15. You can cancel 15 times 1 and this is 15 times 2. So this is equal to 2 times 4 is 8. So you will get how many? 8 pieces. So option P is correct. Now let us see 15th problem. Which one of the following is the rational number lying between 6 by 7 and 7 by 8? So here we have 6 by 7 and 7 by 8. To check which of the following is in between these two, we need to equalize the denominators. So how can we equalize the denominators? Simply multiply 6 by 7 with 8 by 8. So that means this will be equal to 6 times 8 is 48 divided by 7 times 8 is 56. Now second one, 7 by 8 we have. Now let us multiply both numerator and denominator by 7. So that 7 by 7, this is equal to 7 times 7 is 49 divided by 8 times 7 is 56. Now the denominators are equalized. Now here in the options you see, in the denominator, in each case in the denominator we have 112. So 112 we have. So for that, let us multiply the resultant numbers with 2 by 2. So that this will be equal to 48 times 2 will be 96. So 96 by 56 into 2 is 112. So here also times 2 by 2 if you do, this is equal to 49 times 2 is 98 divided by 56 times 2 is 112. So we have 96 and 98, those are in the numerators. So in between those two numerators, what is the number we have? 97. So 97 by 112 will be in between these two. So option C is correct. Now let us go to 16th problem. The following relation is used to illustrate the property of multiplicative identity. Multiplicative identity. So what is multiplicative identity? We know that multiplicative identity is 1. Now A and B are numbers. 1 by 4 into A equal to B. what is the value of A and B. So here multiplicative identity property. So what is multiplicative identity property? X times 1 equal to X. This is what property of multiplicative identity, right? So here we are given that 1 by 4 times A equal to B. Now if we compare these two, in the place of X we have, what is that? 1 by 4. Now in the place of A we have 1. So A equal to 1. Now you compare here these two. B equal to X actually. But what is X? That is 1 by 4. So B equal to 1 by 4. Or we can write like this. We know that 1 by 4 times 1 equal to 1 by 4. Now if we compare this with 1 by 4 times A equal to B. Now in the place of A we have 1. In the place of B we have 1 by 4. So A equal to 1, B equal to 1 by 4. That is the answer for this one. Let us go to the next problem. Observe the number line below. It is given that GH equal to HI equal to IJ equal to JK. So that means all these are equal. That means the interval between -1 and -2 is being divided into 4 equal parts. Now you see here what I am doing. -2, -1 we have. I am writing -2 as -2 times 4 by 4. Why I am multiplying with 4 by 4? Why? Because the interval between -1 and -2 is being divided into 4 equal parts. That is why I multiplied -2 with 4 by 4. So this is equal to -2 times 4 means -8. So -8 by 4. Then -1 equal to -1 times 4 by 4. So this is equal to -4 by 4. Now observe here. Let me zoom it. So -2 can be written as -8 by 4 and -1 can be written as -4 by 4. Now here -4 by 4, after that this point will be -5 by 4 and this point will be -6 by 4 and this point will be -7 by 4. Now what is the rational number represented by point J? So point J is, what is that? -7 by 4. So point J equal to -7 by 4. That is the answer in this case. So for 17th problem, the answer is J equal to -7 by 4. Now let's go to 18th problem. Which of the two numbers is greater? Here the given numbers are -4 by -5. So -4 by -5. And the other number is -5 by 8. Now you see here -4 by -5 means this minus and minus gets cancelled. This is equal to 4 by 5. So 4 by 5 is a positive number. -5 by 8, this is a negative number. A positive number is always greater than the negative number. So we can say that 4 by 5 is greater. So this is the answer for this problem. Next, 19th problem. Use suitable properties of operations and simplify. Show your steps. So here we are given one number. What is the number we have? 2 by 9 times -5 by 12 minus 5 by 12 into 4 by 9. You observe here -5 by 12 here we have and here also we have. So we can take common. But before that, -5 by 12 or -5 by 12 here in this case is at left side to 4 by 9. So let us bring this -5 by 12 to left side of this 2 by 9. So this is equal to -5 by 12 times 2 by 9. So here this one, I am writing this one like this. So that means, what is this property? This property is called commutative property of rational numbers under multiplication. So what is that? So A into B equal to B into A. What is this property? This is nothing but commutative property under multiplication. So I am writing like that. Then the second part, -5 by 12 into 4 by 9 we have. I am writing this one as plus -5 by 12 into 4 by 9. Here I wrote this first part by using commutative property under multiplication. Right. So this is equal to, now -5 by 12 here we have and here also we have. So we can take common. So that means -5 by 12 into If you take negative 5 by 12 as common, this one has gone common. This one is also has gone common. So what are the remaining values? 2 by 9 and 4 by 9. So let us write those values within the brackets. So 2 by 9 plus 4 by 9. What is this property? This property is nothing but distributive property. Changed LHS to RHS and RHS to LHS. What is distributive property? A times B plus C equal to A times B plus A times C. Here I took the right side value and I wrote that as A times B plus C. Right. Now this is equal to minus 5 by 12 into here in the brackets 2 by 9 plus 4 by 9 we have. So denominators are equal. So write this one as 9. You can directly add the numerators 2 plus 4. Why? Because the denominators are equal. That is what we say common denominator. So this is equal to minus 5 by 12 into 2 plus 4 is 6. So 6 by 9. Now you can cancel. This is 6 times 1 and this is 6 times 2. So this is equal to minus. Now multiply the numerators. Negative 5 times 1, that is negative 5, divided by 2 times 9. 2 times 9 is 18. So the answer is negative 5 by 18. So this is the answer for 19th problem. So with that we finished all the problems from this question paper. Right. Hope you understand each and every problem. If you like my explanation, please subscribe my channel, press like button, comment on my explanation and share the link of my channel to your friends, colleagues, students and different WhatsApp groups and share on social media also. Thank you very much. Yours Kona Kiran Reddy.